A study of algebra has to begin with an overview of numbers and basic number operations. So that may seem simple, but it is the groundwork that we build everything else on. Up until this point in math, you've studied numbers, you've studied different types of numbers, and then ways you can operate with numbers. And this lesson is just going to go over how those numbers are represented and some of the basic vocabulary that's associated with number operations. So most of the time when we're dealing with numbers, we like to deal with what are called whole numbers. Let's see if we can write that a little bit better. And you spend most of your elementary school study of math studying whole numbers here. Whole numbers are basically 0, 1, 2, 3, 4, and so forth. The ellipsis or the dots means that this continues going on. When you get to your later elementary school grades, then you start introducing decimals and fractions, which represent pieces of a whole. So up until then, you deal with whole things. So you might, like my elementary school, we used to have like little dots. And so you could have 1 dot or 2 dots. I remember we had them on our desk in 3rd grade. Okay, and you've got like 3 dots, or you have 4 dots. As you get to like 4th and 5th grade, now you start dealing with like pieces of dots. And so you might have 1 and a half dots. Okay, that's like my lame attempt doing a half a dot. And so we need a way to be able to represent pieces of things, and that's where fractions and decimals come into play. And so a fraction has 2 pieces. It's got a numerator and a denominator. And what the numerator and denominator represent are total pieces, okay, that comprise a whole. So total pieces in the whole. And the numerator is how many of those pieces you have. So for example, and we usually do this in elementary school, like if you have a whole candy bar, I don't know if that's candy bar, but you have a whole candy bar, and that candy bar is divided into, I don't know how many, I split it into 6 pieces there, okay? And then you have 2 of them, then this like fraction or like this piece of the whole would be represented as 2 out of 6. So it's divided into 6 equal pieces, and that is assumed that like however many pieces you divide the whole into is equal. That's how many pieces it was divided into, and then the numerator tells you how many of those pieces you have. Years ago, I used to teach with like Hershey bars, because Hershey bars, like a regular Hershey bar, is divided into 12 of like the little bars, and 12 is just a nice denominator because you can split it up a lot of different ways. And so you could see that 2/6 is the same as 1/3. So if you were like to divide this into 3s, the purple part would represent 1 out of the 3. And so that's what your fractions are. And then the next way of representing numbers is with decimals. And you usually don't get to decimals until you start with like division. I don't know. It's been a really long time since I've done like elementary school. But a decimal is based off of place values. So you've got like in a number, we'll kind of go, and then you have a decimal point, okay? And we'll just kind of go out a little bit on either side. This digit is called the units digit. That's like your 1, 2, 3. This digit here is the tens digit. This digit is the hundreds, and so forth. So if you had like 284, Okay, so that third digit over, like the 2 means like 200, and then an 8 in the 10 spot really means 80, and then a 4 in the unit spot just means the 4. Then on the other side of the decimal point, there's actually no corresponding place value for the units, and that's often an element of confusion, even for my Algebra 2 students. Like, that tends to be a little bit confusing. This first one is actually called the tenths spot, and then you have the hundredths and the thousandths. Okay, like that's like not the easiest thing to say. And a tenth represents 1 out of 10. So if you had like your little candy bar and you divided it into 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you pretend it's 10, okay? And you had, say, 3 of them, okay, you would have 3 tenths, and the way that would be represented is with a 3 in the 10th spot. And then if you divide it into hundredths, you could have, 5 hundredths or 35 hundredths is one way you could think of it. Think of money, and so forth. So those are your basic ways of representing numbers. Now we get into operations. So you might hear a teacher talk about like a 4-function calculator or your basic operations, and we want to know what those operations are. So when we talk about operations, there are 4 basic ones, but there are others that we layer on as we continue studying our mathematics. The 4 basic operations are adding, subtracting, which there's really no such thing as subtraction, multiplying, and dividing. And that is not going to surprise anybody who's watching this video, because you've heard that like for a really long time. Add, subtract, multiply, divide. Now, other words that are associated with adding, subtracting, multiplying, and dividing. Sum, okay, that would be the answer to an addition problem. So I could say something like, find the sum of 4 and 5. And that word sum means that you're being told to add. So the sum is the answer to an addition problem. For subtracting, the word is difference. So if I were to tell you my age and I were to say, what's the difference between my age and your age? What I'm asking you to do is subtract. So difference means to subtract. Multiplying, the word that goes with that is product. So the answer to a multiplication problem is called a product. And then the answer to a division problem is called a quotient. And that Q actually comes in handy in Algebra 2. You start talking about the rational numbers, the rational versus irrational numbers. And the rational numbers, the symbol for the rational numbers is a Q, and it comes from quotient. It comes from being able to express the number as a quotient. So you have add, subtract, multiply, and divide, and then the answers to those problems would be sum, difference, product, and quotient. Like quick little examples. Here's like a sum. We could say the sum of 12 and 7 is 19. The difference between 15 and 8 is 7. The product of 3 times 6 is 18. And the quotient of 24 and 3 is 8. Okay, and that's just like a really quick example there. So that's your basic arithmetic, numbers, ways of representing numbers. Hopefully that's not overwhelming. And then we can get into using grouping symbols, and this is going to tap into order of operations, but I am going to do a separate video on order of operations a little bit later that incorporates exponents in it, but we're not really talking about exponents here. Now, there are other operations. So like taking a square root is another operation. Taking an absolute value is an operation. And then as you get further up in math, you could have things like taking the sine of an angle, or taking the logarithm or natural log of a particular number. So there are other operations, but usually when we talk about operations, we start with add, subtract, multiply, and divide, and you don't want to overthink that at all. As we get into the order of operations, if you have a problem that has more than one operation in it, there are rules that govern which operations have to be done first. And typically you do grouping first. So I'm going to work through just a couple of examples. These are order of operations problems, but again, they're not order of operations problems that involve like everything yet. So let's take a look at this one. We have 16 minus, and then we're going to use like what are called nested grouping symbols. Okay, so we have like a square bracket with a like parenthesis on the inside. Now, when you're evaluating something, and I do this with my Algebra 2 students, and I talk about evaluate means to like simplify. Often it means to like plug in and simplify. But if like in this case, there's something to plug in. So it just means to simplify, and it means carry out the order of operations and find what this is equal to. Now, we don't actually need the parentheses on the inside here because order of operations does tell us that we would do the multiplication before we would do the subtraction. But for now, we'll just keep the grouping symbols in there. So if you have more than one grouping symbol, you start with the innermost grouping symbol. So we have like a square bracket, and the only reason like the square bracket is there is to kind of make it look different from the parenthesis. It doesn't actually have any difference in terms of what it does. It's just sometimes when you've got like a lot of parentheses, it gets hard to see where like one parenthesis opens and closes. And so by making them look a little bit different, is a little bit easier on the eyes. So if you've got what are called nested grouping symbols, so a grouping symbol inside a grouping symbol, you always start with the innermost one. Anything that you're not working with, you bring down to the next line. So I'm going to take the 16 and I'm going to bring it down to the next line. I'm also going to take the 6 and bring it down. And I'll start by doing the 4 times 5. Okay. And so 4 times 5 is 20. And notice we're working top to bottom, and everything that I didn't work with gets copied down to the next line. And so if somebody were to look at this and say, wait a minute, Miss Taylor, where did you get the 20 from? You should be able to look like immediately one line above, and that should tell you where the 20 came from. The 20 came from 4 times 5. Now we have one grouping symbol, and so we'll do what's in that. We'll do the difference. So 20 minus 6. And that gives us 14. And notice you don't need the grouping symbol anymore. Okay, once you've carried out the operation, like there would be no point in writing that. Like that's just silly. That's like extra writing. So you don't need that grouping symbol. And now we would do the last operation, which is 16 minus 14, which is 2. Again, notice the top-down structure, like always top to bottom, so that you can follow the flow of what's been done. So if somebody says, well, where did the 14 come from? Well, look right above it. 14 came from 20 minus 6. And your work should have like a structure to it like that. Let's look at one more. This is 210. And then we are using the fraction bar there. And then we'll put 13 minus 3 on the denominator. So this is a little bit of like a slick thing here where there's two grouping symbols, but you don't see two grouping symbols. And that's because the fraction bar is acting like a grouping symbol. So you've got the 210 on the top, and then this is functioning like a grouping symbol, and it's grouping the 20 with the 13 minus 3. Sometimes you'll see like an extra set of parentheses around that for calculator purposes. Okay, you don't need it if you're not using a calculator, but depending on the calculator you use, you might need to add that in, because that's grouping it together. So I've got like a group on the bottom, and then in that group I have another group. I have 13 minus 3, and you start with the most inside part. Copy down the 210, because if you don't, you'll forget about it. 13 minus 3 is 10. And again, you can drop the parentheses once you're down to like one thing in them. You don't need them anymore. Now I've got the grouping symbol of the 20 minus 10. Okay, so 20 minus 10 is 10. And again, copy down the 210. And then that is a division problem. So that is 210 divided by 10, which is 21. And again, notice top-down structure. Okay, it's like top-down structure. You want to keep it nice and organized. So what I'm going to do on the next slide is I'm going to write a couple problems for you to practice on, just to make sure that you've got these concepts down. And if it seems really easy, then that's great. Like, we want math to feel easy and we want it to feel very logical. So I'm going to come over to the next slide and copy down some problems for you. Okay, so forgive my handwriting on here, but here are 8 problems to just reinforce what this lesson was about. Question number 1, what is the sum of 4 and 9? Question 2, what is the quotient of 16 and 4? Question 3, what is the product of 7 and 3? Question 4, what is the difference of 8 and 7? I probably would phrase that, what is the difference between 8 and 7, but of also works. For problem 5, that's 10 plus bracket 9 divided by parentheses 1 plus 2 close parentheses and brackets. 6 is open brackets and parentheses 10 times 3 close the parentheses minus 10 close brackets divided by 4. You might also hear someone say after the second 10, you might hear them say all divided by 4, and the word all is intended to signify like everything that I said before. Number 27 is 28 divided by, and then in the denominator 4 times 2 and then minus 4. And number 8 is 16 minus brackets 54 divided by 3 times 3 close both. So what I would do is pause the video and work these out on a separate piece of paper. Okay, so there might have been a little bit of break in that I had to do a little bit of editing, and I'm not sure if I got it edited the way that I wanted. But to go over the answers, if you haven't paused to work out the problems, do so now because I'm about to go over them. Okay, so for the first one, what is the sum of 4 and 9? That is 13. For the second one, what is the quotient of 16 and 4? That should be 4. For the third one, what is the product of 7 and 3? That is 21. And the fourth one, what is the difference between 8 and 7? And that is 1. And those problems are just an exercise in vocabulary. Give you a chance to read and handle the words so that you can become comfortable with the words. Now, the others involve some work to be done. So what I'll do is I'll work them off on the side, and then you can kind of follow along with them. So for the first one, you've got 10 plus 9 divided by 1 plus 2. And remember, you start with the innermost grouping symbols. So the innermost grouping symbol is the 1 plus 2. So that's going to give you a 3. And then 9 divided by 3 is 3, and 10 plus 3 is 13. Please, please, please work on your structure. So even if you can do the problems in your head, don't do the problems in your head. If nothing else, use these as an opportunity to practice how to structure the problems. For the second one, we have 10 times 3 minus 10, all divided by 4. And again, we start with the innermost grouping symbol, which is going to be the 10 times 3, which is 30. And then we'll do the grouping symbol 30 minus 10, which is 20. And then 20 divided by 4 is 5. And again, notice the structure to the problem and compare that with the structure of your problem. Third one, 28 over 4 times 2 minus 4. And so again, we start with the innermost grouping symbol, and then we go from, like, we'll do the multiplication first because multiplication would come before the subtraction. So 4 times 2 is 8. 8 minus 4 is 4, and 28 divided by 4 is 7. And don't forget about the 28. Don't get lax. I know with fractions can feel kind of awkward when it comes to writing them down. It kind of feels weird. So make yourself do it. Now, 8 has this like slick thing in there, and we haven't talked about order of operations, but so you would start, let me copy this one over. this is actually why I had to go back and edit, because I messed up like this spot, like just the explaining of it. So we've got like the grouping symbol. Now inside the grouping symbol, we have division and then we have multiplication. The order of operation says that you go from left to right going across. So you don't actually do the 3 times 3 first, which is kind of what you might want to do. And it's kind of what I want to do. And there are some calculators that do it, and it's called like implied order of operations, and it drives me crazy. But so what you actually want to do is you want to do the 54 divided by 3 first. The parenthesis there doesn't make a difference. It's like kind of an extra parenthesis around that. So you would have the 54 divided by 3, which is 18. And then you would have the 18 times 3, which is going to bring you right back to the 54. And I'm looking at that and I'm like, I don't think that's what the authors of the people that wrote this problem like intended for you to do. Because now we end up with a negative number, and we haven't really talked about the negative numbers yet. But we get the negative 38, which I don't think is what they intended. Something just tells me, because I got this problem from a book, and I just kind of think that whoever wrote it intended for you to do the 3 times 3 first. And maybe there's some like just because I know Casio graphing calculators will do the multiplication first, even though you are supposed to go from left to right. So maybe that's what they intended, because 54 divided by 9 is 6, and then 16 minus 6 is 10, which is a much simpler problem. But technically, those parentheses shouldn't make a difference. So anyway, last problem aside there, hopefully the first lesson, you've got a pretty good handle on types of numbers and the vocabulary and operations with them.